Hello everyone, in this video we're going to review AP, calculus, AB and BC, topic, errors and volumes. Alright, before we're going to dive into question, let's review some concept behind this topic. Alright, first we're going to talk about the error between two curves. When ds slides in, then we have this formula, where y top and y bottom are written in terms of s. Alright, so in this situation it's going to be the vertical rectangle, right? This one is the height, this one is the width. The height is the distance between the y top and y bottom. The width is ds, right? Now, similarly, dy slides in, you have this formula, where s right and s left are written in terms of y, right? And in this situation, you have the horizontal rectangle. Now, first, we need to sketch the region and draw a representative rectangle to be used in determining whether setting up with respect to ds or dy. Determine the slicing direction. Then find the volume of the slide, which will be the area of the face times the thickness. Determine the total volume by summing up the slides using the definite interval. Lastly, use the following templates to set up a definite interval. ds slicing, you're going to use this formula, where a of s is the area of the surface written in terms of s. dy slicing, you're going to use this formula, where a of y is the area of the face written in terms of y. Now, the volume of a solid of revolution. First, you need to sketch the region to be revolved and a representative rectangle, whose width can be used to determine whether iterating with ds or dy. Second, set up a definite interval after determining whether the slicing using ds or dy, so that the slicing is perpendicular to the axis of revolution. Lastly, identify the outside radius and the inside radius and use the appropriate template from below. Now, this method, ds slicing v equals pi times the interval from left s to right s radius squared ds. Now, dy slicing, we're going to use this formula. Now, next one, the washer method. You're going to use this formula if ds slicing, and this formula if dy slicing. Now, let's move on to question 1. The region enclosed by the x-axis, the line s equals 3, and the curve y equals square root of s is rotated about the x-axis. What is the volume of the solid generated? Alright, so we're going to sketch the figure. Now, we're going to rotate this one about the x-axis. So, we're going to get the solid something like this. So, to find the volume of this one, we're going to use this method, right? The radius is the distance between the function y equals square root of s and the x-axis, right? So, the volume equals pi, the interval from 0 to 3, right? Of square root of s subtract 0, right? Because x-axis, which means y equals 0, right? Square ds. So it could be pi, the interval from 0 to 3 s ds, right? So it could be pi s squared over 2, evaluated from 0 to 3, right? So it could be pi over 2 times 9 subtract 0, It's going to be 9 pi over 2. The answer must be C. Now question 2. What is the error of the region in the first quadrant bounded by the graph y equals e to the s over 2 and the line s equals 2? Alright, so we're going to graph this one. So the error is the interval form 0 to 2. Y top subtract y bottom. Y bottom is the x-axis, which means y equals 0, right? Y top is right here, right? So it could be e to the s over 2 dx, right? Now remember, you have the formula antiderivative of e to the as plus b dx is going to be 1 over a e to the as plus b plus c. So keep that in mind. A in this situation is going to be 1/2, right? So 1 over 1/2 is going to be 2, right? E to the s over 2 evaluated from 0 to 2, right? So it's going to be 2 times e to the 2 divided by 2 is going to be 1, right? Substitute 0 is going to be e to the 0, right? So it's going to be 2 times e minus 1, right? Or 2e minus 2, right? The answer must be A. Now let's move on to question 3. What is the error enclosed by the curve y equals s cubed minus 8s squared plus 18s minus 5 and y equals s plus 5, right? So we're going to bring up the calculator to graph these two guys, right? Add graphs right here. Input the first function. Enter. It's going to be right here. The second one, you just hit tab. Input s plus 5. Press enter. Now you need to adjust the windows, right? So go to menu number 4, number 1, right? S minimum, S maximum is good. Y minimum good, but Y maximum right here. We need to set this one to 20. And then press OK. It's right here. Alright, so the intersection between these two graphs is the guy right here and the guys right here, right? So we need to find the intersection. We have 3 intersections right here, and right here, right? So you're going to hit menu, number 6, number 4, go to the left, go to the right. We have the first one right here, 1, right? Menu, analyze graph, intersection. The second one is right here, as equal 2. And the third one, menu, analyze graph, number 4. And the third one is 5, right? So we have 3 intervals, right? From 1 to 2, the cubic function is above the linear function, right? But from 2 to 5, the cubic function is below the linear function, right? So the error is the interval from 1 to 2. This guy right here, subtract this one, right? Plus the interval from 2 to 5. This guy above this guy, right? So it could be s plus 5. Subtract this guy right here. We need to change the sign, right? So s cubed plus 8s squared minus 18s plus 5 ds, right? So we're gonna print up the calculator. Alright, the best way for you to do it is to store the function, right? So I'm gonna go to home screen, hit calculate. Now I need to input the function FOS first, right? FOS is the first one and GOS is the second one. Hit Control and the button right here. Input the function right here. And then press enter. Now you do exactly the same thing for GOS right here, right? Now you're gonna hit the button right here, input the interval. Interval from 1 to 2. FOS subtract GOS, right? Plus the second one is going to be interval from 2 to 5. GOS subtract FOS. And then press Control Enter. It's going to be 11.833. The answer must be B. Question 4. The region bounded by the x-axis and the part of the graph of y equals cosine x between x equals negative pi over 2 and x equals pi over 2 is separated into two regions by the line x equals k. If the area of the region for negative pi over 2 less than or equal to x less than or equal to k is 3 times the area of the region for k less than or equal to x less than or equal to pi over 2, then k equals how much? Now let's get the graph of the function y equals cosine x. You know that the function y equals cosine x has the period 2 pi, right? So this is 0, this one is 2 pi. Half of 2 pi is pi. Half of pi is going to be pi over 2. And half of this one should be 3 pi over 2, right? And you know that the function cosine starts from the maximum is going to be 1, right? The minimum right here should be negative 1. It starts from here, go down to the midline, go down to the minimum, back up to the midline, and go back to the maximum, right? So it's going to be something like this. Now we're going to duplicate this one to the left, and we have this one. So the region should be this guy right here, from negative pi over 2 to pi over 2, right? And the line s equals k should be somewhere right here. This is k, right? Where the area of the regions for negative pi over 2 to k, right, is 3 times the area of the regions for s between k and pi over 2, right? So which is the yellow one equals 3 times the green one right here, right? So we have the integral form negative pi over 2 to k of cosine x dx equals 3 times the integral form k to pi over 2 cosine x dx, right? Now antiderivative of cosine should be sine x evaluated from negative pi over 2 to k equals 3 times sine x evaluated from k to pi over 2, right? So it's going to be sine k subtract sine of negative pi over 2 equals 3 times sine of pi over 2 subtract sine k, right? Now sine of negative pi over 2 equals negative sine of pi over 2. Sine pi over 2 equals 1, right? So this one turns out to be sine k plus 1 equals 3 times sine pi over 2 equals 1. So it could be 3 minus 3 sine of k, right? So it's going to be 4 sine of k equals 2, right? Sine of k equals 1/2, right? Then k equals pi over 6. So the answer must be C. Now let's move on to question 5. Let R be the region in the first quadrant bounded above by the graph of y equals square root of x and below by the graph of y equals x squared. R is the base of a solid whose cross-section perpendicular to the y-axis are squares. Which of the following gives the volume of the solid? Alright, so let's get the figure. The region R is the base of the solid whose cross-section perpendicular to the y-axis. Alright, so the radius is going to be like this. And the cross-section is the square, right? So it could be something like this. Now since the cross-section perpendicular to the y-axis, then your integral must be in terms of y, right? So we need to eliminate a and b, right? Now you need to find the area of the square, right? Now the side length is the difference between y equals s squared and y equals square root of s. We need to rewrite two functions right here in terms of y, right? So square both sides, it could be y squared equals s, right? So s equals y squared, right? And this is s left, right? Now for this one, we need to solve for s. We're gonna take square root both sides, right? So we have s equals plus and minus square root of y, right? But in the first quadrant, s is positive, right? So s should be equals square root of y, right? And this one is s right, right? Look at this one right here. Now we need to find the intersection between two graphs right here, right? So we just let this guy right here equals this guy, right? So we have s squared equals square root of s, right? We're going to square both sides, so we have s to the 4 equals s, right? We're going to subtract s both sides, so we have s to the 4 minus s equals 0. Factor s out, so we have s times s cubed minus 1 equals 0. Then each of this one must be equals 0, right? So s equals 0 and s equals 1, right? So this one is 1 right here, right? Now we substitute 1 for s into one of the equation right here, right? So we have y equals 1, right? Substitute 0 for s into this one right here. We have y equals 0, right? So this one is 0, this one is 1. We have the integral form 0 to 1, right? S right subtract s left, right? S right is right here. So we have square root of y subtract s left is right here, y squared, right? dy. And this one right here is the side of the square right here. We need to find the error of this one, so we need to square the side, right? The answer must be C. Now let's move on to question 6. Let R be the regions in the first and second quadrants bounded above by the graph y equals 20 over 1 plus s squared and below by the horizontal line y equals 2. R is the base of a solid whose cross-section perpendicular to the x-axis and semicircle. What is the volume of the solid? We are allowed to use the calculator, right? So we're going to graph this guy on the calculator. We're going to hit on, go to home screen, hit graph, input the function right here, right? So we're going to hit the button right here, put the fraction. Analyze y equals 2. So we're going to hit tab, put 2, hit enter. It's going to be right here. Now we need to find the intersection. So we're going to hit menu, number 6, number 4. Go to the left, go to the right. It's going to be -3, right? We're going to do exactly the same thing for the second one, right? The answer is 3 right here, right? So we're going to grab this one right here. Now the cross section perpendicular to the axis. So diameter should be the difference between two graphs right here, right? So we're going to draw the semicircle. It's going to be like that, right? Now we need to find the radius of the semicircle in order to find the area of the semicircle, right? Now the distance from here to here actually the diameter, right? So diameter equals 20 over 1 plus s squared subtract 2, right? So we're going to divide both sides by 2 to get the radius, right? So this one I'm going to multiply by 1/2, right? And this guy actually the radius, right? So the radius square equals 1 over 4 times 20 over 1 plus s squared minus 2, right? And the volume equals the integral form -3 to 3, right? Times a of s ds, right? A of s is the error of the semicircle, right? So it could be v equals the integral from -3 to 3 of pi r squared divided by 2, right? So I have pi divided by 2 in the front, right? Now r squared right here is actually 1 over 4 times 20 over 1 plus s squared minus 2 altogether squared, right? This one must be square. I'm gonna bring up the calculator. Now we're gonna go to home screen, hit calculate, hit the button right here, pick the integral from -3 to 3 of 1 over 4 1 over 4 times pi over 2, it could be pi over 8, right? So I'm going to put pi over 8 here times and press Ctrl Enter. It's going to be 174.268. The answer must be B. Now let's move on to question 7. The function f and g is given by f of s equals 2 square root of s and g of s equals s minus 3. Let R be the region bounded by the s-axis, the graph f and g. The graph of f and g intersect in the first quadrant at the point 9, 6. Which of the following gives the volume of the solid generated when R is revolved about the s-axis? Alright, so we're gonna sketch two functions right here first, right? Alright, so here's the graph of the region R after revolving about the x-axis, right? The yellow one is the initial one, and then after you revolve this one about the x-axis, you get the green one right here. Alright, so in order to calculate the volume of this solid, we need to separate this guy into two portions. The first one, the integral from 0 to 3. This one is the solid one. We need to use the disk method, right? Because we don't see the hole right here, right? And the second one, from 3 to 6 right here, we need to use the washer method because we have the hole in the middle right here, right? Alright, so I need to calculate the volume using the disk method first, right? So V1 equals pi times the integral from 0 to 3 of radius square. The radius is the distance from the function y equals 2 square root of s to the x-axis right here. Right? This is the radius. So it's going to be 2 square root of s subtract 0. It's going to be 2 square root of s, and then you square this one ds. Right? So it's going to be 4 pi times the integral from 0 to 3 square root of s squared is going to be s ds, right? So we're done with this one. Now the second one is going to be the integral from 3 to 6. We need to use the washer method, right? So we put pi right here, the outer radius, which means the bigger one right here, right? So it could be the difference between y equals 2 square root of s and the x-axis, right? So it could be 2 square root of s square. Subtract the inner radius, it could be right here, right? So it could be the function right here. S minus 3 subtract 0, right? The x-axis is y equals 0 altogether square. Then we put ds outside. Right, I'm gonna simplify this one. It's gonna be pi integral from 3 to 6 for s subtract s minus 3 altogether square ds. Right, finally v equals v1 plus v2, right? So the answer must be A. Now let's move on to question 8. The function f is given by f of s equals ln(s). Which of the following limits is equal to the error between the graph of f of s and the x-axis from s equals 1 to s equals 3? So you know that the integral from a to b of the function f of s ds equals limit when n approaches infinity of the summation k goes from 1 to n of f of s k times delta sk, right? Where delta sk is the width of the rectangle, right? And this one is the height or the length, right? So in this situation, we need to calculate the integral from 1 to 3 of ln s ds, right? So the function f of s is right here, right? Now delta s is given by the formula b minus a over n, right? b equals 3, a equals 1 over n, right? So it could be 2 over n, right? Now f of sk is calculated as f of a plus delta sk times k, right? So it's going to be f of 1 plus 2 over n times k, right? Or f of 1 plus 2k over n. Function f of s is ln s, right? So it's going to be ln of 1 plus 2k over n, right? So we substitute this guy right here and this guy right here into this guy right here, right? So the integral from 1 to 3 of ln s ds equals limit when n approaches infinity of summation notation k goes from 1 to n of f of sk is going to be right here. ln of 1 plus 2k over n times delta s, which is 2 over n. So the answer must be A. Now let's move on to question 9. Let R be the region enclosed by the graph of f of s equals s to the 4 minus 2.3 s cubed plus 4 and the horizontal line y equals 4 as shown in the figure above. Question A. Find the volume of the solid generated when R is rotated about the horizontal line y equals negative 2. Now y equals negative 2 is going to be right here. Alright, so this one is axis of revolution, right? So the volume equals, now when you rotate the region R about this line right here, we're gonna create the solid that its volume will be calculated using the washer method, right? Because you have the hole, right? So the inner radius is right here. And the outer radius is right here. Right? The inner radius changes depending on the function f of s right here. Right? And the outer radius remains unchanged. Right? This one's y equals 4. Right? So the volume is the integral from 0 to this guy right here, right? So we need to find the intersection between this guy and this guy, right? Now we need to bring up the calculator. Add graphs right here. The first one, we need to input the function f of s right here. And the second one, y equals 4. So you're gonna hit tab, hit 4, press enter. It's gonna be right here. Right? Now we need to find the intersection right here, right? So we're gonna press menu, number 6, number 4, go to the left, go to the right. It's gonna be 2.3, right? So we have the integral from 0 to 2.3, right? Don't forget to put pi in the front, right? the outer radius is the difference between 4 and negative 2 right here, right? So 4 minus negative 2, which means add 2 altogether square. Subtract the inner radius, the difference between f of s right here and the line right here, right? So it could be s to the 4 minus 2.3 s squared plus 4 subtract negative 2, you're gonna add 2, right? Square and then ds. Now we're gonna print up the calculator to calculate this one. Hit calculate, copy this one down. Alright, we're gonna put pi in the front. In row form 0 to 2. Press Ctrl Enter. It's gonna be 98.867. Now question B. Region R is the base of the solid. For this solid, its cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in the region R. Find the volume of the solid. Alright, so region R is right here. Now the cross-section is perpendicular to the x-axis and the shape is the isosceles right triangle where the leg is on the base, right? So the leg is right here. So you know that the area of the right triangle, this is the right angle right here, right? This hypotenuse right here. The leg is here and the leg is right here, right? Now the leg is the difference between y equals 4 and the function f of s right here, right? So it should be 4 subtract f of s, right? Since this one is the isosceles right triangle, so this is leg 1, this is leg 2 is still 4 minus f of s, right? So the error should be base times height divided by 2, right? So it could be 4 minus f of s altogether square, right? Divided by 2, right? The volume should be the interval from 0 to 2.3 of 4 minus f of s altogether square divided by 2 ds, right? So we're gonna print up the calculator. We're gonna copy this one down over here. The interval from 0 to 2.3 of 4 minus f of s is s to the 4 minus 2.3 s cubed plus 4, right? Divide by 2, right? So I'm gonna multiply by 1/2. Press Ctrl Enter. It's gonna be 3.574. Now let's move on to question C. The vertical line s equals k divides the region R into two regions with equal area. Write but do not solve an equation involving integral expression whose solution gives the value of k, right? So suppose the line s equals k is right here. So does that mean the volume of this region from 0 to k equals the volume of this region from k to 2.3, right? So we just set up two integrals, right? Equals the integral from k to 2.3 of 4 subtract f of s ds, right? Question 10. Let f of s equals 2s squared minus 6s plus 4 and g of s equals 4 cosine of 1 over 4 pi s. Let R be the region bounded by the graphs of f and g as shown in the figure above. Find the area of the region R, right? So it's going to be the integral from 0 to 2. Y top subtract y bottom, right? Y top is right here, y bottom is right here, right? 4 times 4 over pi sine of pi over 4s evaluated from 0 to 2. Subtract 2 over 3s cubed minus 3s squared plus 4s evaluated from 0 to 2. Now recall the antiderivative of cosine of as plus b ds is going to be 1 over a sine of as plus b plus c. Keep that in mind. Now we're going to substitute 2 for s, right? So 4 times 4 equals 16, so 16 pi times. Substitute 2 over here, we have sine of pi over 2, subtract sine of 0. Subtract. Substitute 2 over here, it could be 8. 8 times 2, it could be 16, so 16 over 3 minus 12 plus 8. And then substitute 0, it could be 0, right? Now, sine pi over 2 equals 1. This one equals 0, so it could be 16 over pi. Subtract 16 over 3 plus 12 subtract 8. So the final answer should be 16 over pi minus 4 over 3, right? Question B. Write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 4. Now this slide y equals 4. The inner radius is the distance from here to here, right? The outer radius is the distance from here to here, right? So the volume equals integral from 0 to 2. Don't forget pi right here. The outer radius square, subtract the inner radius square, right? Outer radius is difference between y equals 4 and the function f of s right here, right? So we have 4 subtract f of s altogether square, subtract the inner radius, the difference between y equals 4 and the function g of s right here, right? It's going to be right here. So it could be 4 subtract g of s altogether square ds. Now let's move on to question C. The region R is the base of a solid. For this solid, its cross-section perpendicular to the x-axis is a square. Write but do not evaluate an integral expression that gives the volume of the solid, right? So the cross-section is something like this. The side length is the difference between the top function and the bottom function right here, right? So you know that the volume of the solid using the cross section is going to be the integral from 0 to 2 of a of s ds, right? Because the cross section is perpendicular to the axis right here, right? So it could be integral from 0 to 2. The sine square, but the sine is the difference between top and bottom right here. Top is the cosine function, right? So it could be g of s subtract bottom, which means f of s, right? And then square, right? Because this is the area of the square, ds. Now let's move on to question 11. The function f and g is given by f of s equals square root of s and g of s equals 6 minus s. Let R be the region bounded by the x-axis. The graphs of f and g as shown in the figure above. Find the area of the region R. Alright, so we need to separate this one into two sections, right? So the integral from 0 to 4, the top is this guy, and the integral from 4 to 6, the top is this guy, right? So the area of the region R is the integral from 0 to 4 of f of s subtract y equals 0 right here, right? So it could be square root of s ds plus the integral form for to set up this one, right? So this guy actually the right triangle, right? So it's gonna be base equal 2 times height equals 2, right? So plus 2 times 2 divided by 2, right? So it's gonna be 2 over 3s power of 3 over 2 evaluated from 0 to 4 plus 2. So it could be 22 over 3. Now question B. The region R is the base of a solid. For each y, where y between 0 and 2, the cross-section of the solid taken perpendicular to the y-axis is a rectangle, whose base lies in the region R and whose height is 2y. Right, but do not evaluate an integral expression that gives the volume of the solid. Alright, so we go back over here. The base is right here. We need to rewrite the function fs and gfs in terms of y because the cross-section perpendicular to the y-axis, every single thing must be in terms of y, right? So fs equals square root of s. We have y equals square root of s, square both sides, so it could be s equals y squared, right? Now for this one right here, y equals 6 minus s, then s equals 6 minus y, right? And this is right, this is left, right? So the volume equals the integral from 0 to 2 right here, right? Of a of y dy, right? So it will be integral from 0 to 2. The base of the rectangle is the difference between g of s and f of s, right? So we have g of s is going to be 6 minus y right here. So 6 minus y subtract f of s is going to be y squared right here, right? dy. The height is 2y, right? Now let's move on to question 12. Let R be the region in the first quadrant enclosed by the graphs of y equals 2s and y equals s squared as shown in the figure above. Find the area of the region R. Alright, so we have A equals the integral from 0 to 2, right? Y top subtract y bottom. Y top is the linear function right here, which is 2s, right? Y bottom is s squared ds, right? So it's going to be s squared minus 1 over 3s cubed evaluated from 0 to 2, right? So it could be 4 minus 8 over 3, right? It could be 4 over 3. Now question B. The region R is the base of a solid. For this solid HHS, the cross-section perpendicular to the axis has an area A of s equals sine pi over 2s. Find the volume of this solid. So it could be V equals the integral from 0 to 2 because the cross-section perpendicular to the axis, right? So we're going to use the left and the right hand bound, right? Of A of s ds, right? So it could be integral from 0 to 2 sine of pi over 2 s ds. So it's going to be negative 2 over pi of cosine of pi over 2 s evaluated from 0 to 2, right? Remember you have antiderivative of sine of as plus b ds is going to be negative 1 over a cosine of as plus b plus c, right? So we substitute 2 per s is going to be negative 2 over pi subtract cosine of 0, right? Now cosine of pi equals -1, so it could be -2 over pi times -1. Cosine of 0 equals 1, so it could be -1. So the answer is 4 over pi. Now question C. Another solid has the same base R. For this solid, the cross-section perpendicular to the y-axis are square. Right, but do not evaluate an inverse expression for the volume of the solid, right? So we have the cross-section perpendicular to the y-axis, so it should be in terms of y, right? So we're gonna go back over here. The cross-section right here is a square, right? So it could be something like this, right? So V equals the integral from 0 to 4 right here, right? The sine of the square is the difference between the function y equals s squared and y equals 2s right here, right? Now we need to rewrite two functions right here in terms of y, right? So we have s squared equals y. Take square root both sides, so it can be s equals plus and minus square root of y, right? So we're going to pick the positive one because it's on the first quadrant, right? Now this one right here, y equals 2s, right? So s equals y divided by 2, right? So it's going to be square root of y subtract y divided by 2. And the area of the square equals sine times sine, right? So it could be this one square dy, right? Now let's move on to question 13. Let R be the region bounded by the graph of y equals sine pi s and y equals s cubed minus 4s as shown in the figure above. Alright, so this one actually is y equals pi s and this one's y equals s cubed minus 4s, right? Now find the area of the region R, right? So it could be the area of the region R equals the integral from 0 to 2. Y top subtract y bottom, right? So it could be sine of pi s subtract s cubed minus 4s ds, right? Now since we are allowed to use the calculator, so we're going to bring up the calculator. So I'm going to store the function sine pi s first, right? Hit control and the button right here, put sine of pi s, press enter. Now second one, I'm going to store the function g of s. So I press g of s, press control and the button right here, input s cube minus 4s, press enter, right? So now I just hit the button right here, input the integral right here, integral from 0 to 2 of enter, it's gonna be 4. Question B. The horizontal line y equals -2 splits the region R into two parts, right? But do not evaluate an integral expression for the area of the part of the region R that is below this horizontal line, right? So y equals -2 is gonna be right here. So we need to calculate the area of this one right here, right? Now we need to find the intersection between this guy and this guy, right? So we need to use the calculator, right? Hit add graphs right here, input the function fs, press enter, it's gonna be right here. And the line y equals -2, so press tab, put -2, press enter, it's gonna be right here. Now we need to find the intersection right here, right? So we're gonna press menu, number 6, number 4, go to the left, go to the right, it's gonna be 0.539, and menu number, seat number for go to the left, go to the right, it's going to be 1.68, right? So your error should be the interval from 0.539 to 1.68. The top subtract the bottom, right? Now question C. The region R is the base of a solid. For this solid, its cross-section perpendicular to the x-axis is an equilateral triangle. Find the volume of this solid, right? The cross-section is the equilateral triangle, right? Now we need to find the side length of the equilateral triangle first, right? So the length equals the difference between this guy and this guy, right? So it could be sine pi s subtract s cubed plus 4s, right? And you know that the area of the equilateral triangle is going to be square root of 3 over 4 times the sine square, right? So the error should be this guy right here, square, right, times root 3 divided by 4. The volume should be the interval from 0 to 2 of this guy, right? Now we're gonna print up the calculator. Go to home screen, hit calculate. Now previously we store function fs and gos right here, right? So we just use this right here. We put root 3 over 4 in the front. So hit this button, put a fraction right here. Then the interval from 0 to 2 of fs subtract gos, right? fs is sine of pi s right here. Then don't forget to put square outside. Then press Ctrl Enter. It's going to be 4.321. Now let's move on to the last one, question D. The region R models the surface of a small pond. At all points in the region R at a distance s from the y-axis, the depth of the water is given by h of s equals 3 minus s. Find the volume of water in the pond, right? Alright, so let's sketch the rectangle. It's going to be like this. Alright, so this is the depth, right? The depth equals 3 minus s, right? And the length is the difference between this guy and this guy, right? So basically, the cross section is the rectangle. So the length is still this guy right here. So the volume should be the interval from 0 to 2, right? Of 3 minus s times sine pi s minus s cubed plus 4s ds, right? Print up the calculator. Right here you just put 3 minus s and remove the square right here. And then press Ctrl Enter. It's going to be 8.369. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.